Hey, what's up guys, my name is Cherno. Welcome back to the code review of a game about a flying dog that we started a while ago. I suggested in the last episode of this kind of code review, which is this video over here, that I should maybe break it up into different topics, and you guys seem to like it, so here we are. The new code review. Okay, so what should we look at today? I think if we go back to like game.cpp. So yeah, last episode we obviously looked at, I think I just noticed the fact that a lot of these variables were being passed by const reference, and that wasn't really necessary because we can just pass them by value like that. They're pretty small, 4 bytes. And I think a good thing today maybe to talk about is like what on earth is going on here, because this is, interesting. This is such a mess. Like, just reading this is making me upset. Why are these comments indented? Okay, so I'm just gonna kind of go through this, and like we'll clean it up and we'll organize it as we go. So first of all, if you know me, you know that I don't like to have the private stuff first. I used to do that because I think ultimately I used to do that because back in Java, in the Java days, because for those of you who don't know, I started with Java, you'd kind of have, you know, your public class game or whatever, and then, you know, if this is Java code, pretend, and then you'd have like, you know, private int, you know, whatever here, and then you'd have like maybe some public functions, right? This is me writing Java code. So that kind of makes sense, right? Because you kind of, everything's in this class, and usually you put your variables at the top. It would be weird to put them at the bottom. But in C++, because we have header files, what I prefer doing is, because that header file is ultimately like, you can look at it as like a representation of like what that class provides. Like, what is this class? I think a better way to put this is maybe kind of like, what can this class do for me? And obviously when you look at a class, like when you're not writing the actual functionality of the class, but when you're just using the class, which ultimately like that's what happens in programming, especially if you're working in a team with like a lot of people, you're usually like using a whole range of different kind of functions, and you're using other people's code and other people's APIs that they've written. You're working on your own features, but you're not necessarily drilling into every like class that you encounter and changing stuff in it, or at least you probably shouldn't be. And so because of that, it makes sense to me, like if I was to open up any class like this, I want to see what it can do for me. Like, I want to see, like, you know, what can this class do? And obviously when you look at a class and the first thing you see is all of this private code, it kind of just, like, this is like the implementation details of how this class works behind the scenes. That's really what like private stuff is, right? Because you can't use it outside of this class. It's stuff that is like internal to the implementation and the functionality of this actual class. It's almost like a black box. It should be like kind of hidden. And so by that logic, if we open up this class and we see this stuff first, and we have to scroll down a while to see like, oh, these are the functions that we can actually call to, you know, use this class, that's just a bit like, you know, suboptimal. Like, I'd like to basically be like, hey, you know, this is the class called game, right? And this is what it can do for me. That makes so much more sense to me. So what I'm going to do is I'm going to pop this private section down here. So that's what I like to do. If we just kind of look at this, you know, if I zoom out and we look at this, you know, we have the public stuff first, and then we have the private stuff. Now, if there are private functions, which there are not here, then I would also kind of use another private label to kind of divide that, so that I could have, you know, private functions here, and then the variables are here, just to kind of enforce some kind of organization and separation, just to get the code to kind of look cleaner, is what I do. And similarly, like up here, if I had like some subtype here, like, I don't know, subtype, or say a struct over here or whatever, I'd have that kind of separated by public label so that it's not just that. It's just something I do to kind of organize the code a little bit better. Now, a lot of these functions I can see end in semicolons for some reason. You don't need to do this. You do if it's like a declaration, but if it's actually defined like this with a body, then typically like you wouldn't put this here. So that's like another thing I'm noticing. So, you know, some of this like formatting spacing is a bit annoying, but nothing too dramatic. I'm just literally fixing this just for me. Guys, guess what? I have a little secret. This video is sponsored by Brilliant.org. Why is this a secret? Because Brilliant.org is one of the best places on the internet to learn about various STEM topics, such as math, computer science, data science. They have a large collection of really, really high quality courses on those topics. If you're new to computer science and struggling to kind of wrap your head around programming, then they have some really good beginner courses that will kind of hold your hand and teach you the basics. And the thing that sets apart Brilliant is that their courses are really visual visual, engaging, and interactive. Like, for example, calculus. Calculus can be really, really difficult to just kind of picture in your head. So they'll give you like these widgets that you can play with so that you can visually see how it works. It's such a good way to learn. And if you're making games like this flying dog game, you'll probably want to know a little bit of like linear algebra and trigonometry. And they have that. They have that in this kind of visual engaging format where they'll also continuously quiz you to make sure that you're retaining this information. And the best part is the Brilliant have a 30-day free trial, so you can try out everything, just see what kind of courses they have, see how they work for free for 30 days. Just go to brilliant.org/Cherno, link will be in the description below. And if you do go on to like it, then Brilliant have been nice enough to offer 20% off an annual membership to the first 200 subscribers to sign up. Huge thank you to Brilliant, as always, for sponsoring this video. So a lot of these are obviously just declared. They just have like a semicolon, and that's just saying that there's a function called clean, but the functionality is like here. Right, so you've separated it, but there are some areas obviously where you've kind of you've defined the function inline, kind of like this, which just means that you've got the actual body of the function sitting here in the header file. Lots of people ask why, like, how do you decide what to do? It used to be like, I honestly, like, just full disclosure, I don't know if this is still the case, but I had heard throughout my career at EA and everything that if you declare a function kind of inline like this, it kind of tells the compiler, like the compiler is more likely to inline that function. I don't really see why that would be the case. I don't know if that's just a myth. I'm happy to learn something in this kind of circumstance, but basically it's kind of like marking the function inline, which these days doesn't really do anything. Like the compiler usually doesn't, the inline keyword's used for something else, which if you guys watched my global variables video, which I'll link up there, I covered that, the inline keyword for like, or a use of the inline keyword in that video. And then of course in MSVC, you can do something like force inline if you actually want the compiler to kind of treat that seriously and inline the function. If you don't know what inlining functions means, by the way, it just means that instead of whoever calls this function actually like jumping to a different part of the code, so like in assembly, you'd have like an instruction called call, which is really like just like a jump instruction, pushes like a return address to the stack, jump instruction somewhere else in the code base, and then executes the function, then jumps back to where you were. All this jumping, can actually slow down your code quite a bit, actually. You'd be surprised at just how much time that actually takes, especially if you're obviously, your code's made of functions, so you're doing it all the time. Inlining means take the contents of the function and just plop it there. So instead of having to jump somewhere else to execute the instructions for that function, you'll just copy those instructions and put them here inline so that you can just execute the instructions along with like where you currently are. Now that can increase your binary size. If you have like big functions and you're always inlining them, then instead of jumping somewhere else, it could actually increase the size of your binary, which that could also be an issue and slow down your code because suddenly less instructions can like fit onto a cache line. So it's kind of a bit of a balancing act. It's like, do I jump and therefore like ruin my cache that way, or do I just have too much stuff here? But of course, when you have like a one line kind of, function like this, then it does make sense to just kind of inline that code. And if we go into like Visual Studio settings here and even look at something like release, if we go to like C++ optimization, you can see there's this inline function expansion, which even in the release mode is actually just set to default. Usually if you want a really fast build, you change that to any suitable, and that will kind of potentially increase that binary size, but usually this will actually speed up your code by quite a bit. So that's a little trick there. And all of that is because, inlining generally, especially like really, small kind of functions, is a lot faster. But again, that doesn't mean that you have to declare them here necessarily. That's why I'm saying it might be a myth that like declaring them like this means the compiler is more likely to be like, yeah, that's inlineable. But still, if it is just like a simple return or maybe like a couple lines of code, I generally will just declare it in the header file just because like this is not going to change. When thinking about whether or not to declare things in header files, there are a few considerations to make outside of just like what the code looks like. And that is if this code is likely to change. So for example, maybe we have a function here and we might like need to change parts of it. As soon as you change something in a header file, every single CPP file that includes the header file has to be recompiled, because remember, header files themselves, they're not sent to the compiler. Instead, what happens is they get just like copied and pasted into a CPP file. So we have like game.cpp that includes game.h. So what happens is this whole file kind of gets copied and pasted in place of this, and that is what your code looks like when it gets sent to the compiler. And of course, this happens recursively. So like, game.h will include like all of these things, so they'll also be kind of put into this. And so what you end up with is an absolutely huge file. In fact, if we really want to drill deep into this, I guess is what we're talking about today. See, the funny thing is I never know what we're going to talk about. In fact, I was sure I was going to start by talking about like this whole mess here, and I promise we'll get to that probably in a future video. But, you know, why not go deep? That's the whole beauty of this series and this new kind of format, the fact that I can go deep. So I'm really enjoying that. You know, I used to play table tennis back in the day. I was quite good at it, if I do say so myself. And one of my favorite shots to do would be like I would kind of go back and then I'd like hit it like kind of up in the air just kind of for fun, and it would usually land like, you know, if this is the edge of the table, it would land like here, like, you know, on the opponent's side. And so I always used to call myself Team Deep, because like, you know, Team Deep would kind of just get it really deep into their court or onto their table, I guess. So yeah, a bit of a random story, but I need to get like some Team Deep t-shirts made or something. All right, so if we go into preprocessor, we can turn on preprocess to a file. I wonder if I restart Visual Studio if it'll make it bigger. Yes, it will. It's because I kind of changed scaling midway through this episode because I forgot that I like to scale stuff up for you guys. So preprocess to a file, if we turn that on, and I'll just do it for all configurations, then we can actually kind of see the result of what's happening. So if we go to game.cpp and I hit Control F7 to compile just that one file, if I just go to like the directory of where it would have output that file to, so remember, every one of these .cpp files, they become .obj files. So if we go into like probably here, we have this game.obj file, which is like the actual compiled like machine code. And then we have this .i file because I did the preprocess to a file, and you can see it's like 2.25 meg. So if I drag this into Visual Studio, because it is a text file, then you'll see a file that is 123,000 lines of code. And you can see that especially around the bottom, like game, you know, close music, if we go back to our game.cpp, look, it's here, right? So it's the same code, but this only has 500 lines of code. This has 123,000. Why? Because this version that's in the .i file, what that's done is it's recursively gone through all of these includes and included them. And so this is actually like this preprocess to a file thing is really cool because it lets you see what actually is sent to the compiler. And by the way, I'm doing this obviously in Visual Studio and MSVC, but every compiler has this function. You just need to Google it. So yeah, this lets you see exactly what's sent to the compiler, which is really, really useful because not only can you kind of maybe like figure out why things seem fine in Visual Studio, but then eventually they break when you try and compile, it lets you see like obviously everything that's been included. Like look at this, all of this code. In fact, if we go down to our code, of course we know it was like 500 lines of code. So if we just scroll up a little bit, so this is like, this is the beginning of our CPP file. If we go up to the very top, oh, I actually included this here, didn't I? That's funny. But let's go back to what this was, which was just like include game.h, Control F7, this will kind of refresh. So you can see this kind of SDL renderer, that's the beginning of our file. And then from here, it's including stuff from game.h. And this is the header file that you can see is pasted in. And before that, it's including stuff from like the library here, the algorithm header. And that's because if we go to the header file, you can see we're including algorithm. So the point is, it's kind of including all of these files here. But what's really cool is that not only does this kind of preprocess to a file obviously show you what the preprocessor does and like all of these includes, it can also expand all of the macros that you have, right? So stuff like this, SDL init everything. What is that? That's a define. And it's a define that like expands to basically like this or that or that or that or that. So it's bitwise ORing all of these kind of things together to create like a value really. And you can see that's happening inside the if SDL init. If I go back to that file over here, to our preprocessed file, you can see what I have here is if SDL init, and I can see that. Right? This is what it's expanded to. And flags here is SDL window full screen, but that's not a macro, that's an actual enum. That's why it kind of hasn't been expanded. Mix default format is obviously like a macro, and we can see if we scroll down here that it's this value over here. So my point is, when you have complex macros, this one's not very complex, but if you had like something that actually was a complicated macro and you just had no idea what it expands to, and it's very difficult to debug. Sometimes when you're writing macros and you're trying to, I don't know, do some kind of fancy like variadic macros where they have like a variable amount of arguments and you're not sure if it's quite expanding correctly. I remember when I was writing Hazel and I was doing like the logging kind of library for that, as well as like asserts and stuff, I wanted them to be able to take in no arguments potentially, so I could just, you know, log like a blank line or something if I wanted to, or they could take in just a string, or they could take in a string and then a bunch of parameters that get injected kind of into that string. So it was kind of difficult to do that just like in my head and try and compile it. Oh, there's a compiler, or what is does it exactly, but with this preprocess to a file, I can actually kind of see what that code is being generated into. I can see what the macros become. So yeah, that's my little tip of the day, I guess. The preprocess to a file, very, very useful stuff. But of course, game.h, it's included into a bunch of different places. And actually, here's another tip. I'm just full of tips today. If we go into here and maybe like all options, and I'll just type in include here, there's this thing called show includes. Now, I don't know exactly where. Okay, it's in advanced. So C++ advanced. So show includes. So if I turn that to yes, and again, I'll just go back into game.cpp. Let me actually turn the preprocess to a file off. So it's in preprocessor. Just do no. If I do Control F7, then now you can see I actually get like this huge list, which let me just dock this over here so it doesn't interfere with the face cam. Maybe even over here. You can see I get, like, I'm compiling this one file and it's telling me what it's including and also the level that is being included at. So you can see like the way that this indents is, it depends, like, it's saying that game.h, like this file includes game.h and game.h includes this file. And then this file, SDL, includes SDL main, which includes SDL, standard in standard in C or whatever .h. You can kind of see like the whole hierarchy of includes here, which is actually really, really useful when you have like errors because of like your include order or because of recursive includes. If somehow down the line you're trying to compile a file and it includes something and it's not meant to include something. So again, another example from Hazel is we support multiple different rendering backends. So we might have like Vulkan. We used to support both Vulkan and OpenGL, but that kind of Vulkan code should never be included by any client application. So basically Hazel at its core, like the core engine, that's allowed to use Vulkan, but then like, the Hazel runtime, which is like the actual game application, or Hazelnut, which is the level editor, that doesn't even have Vulkan, like the Vulkan header files in its include paths. Like it can't be there, which is why if we do include something that uses Vulkan, we'll get a compile error because it will tell us that, hey, I can't find vulkan.h because it's not kind of in that module, because it shouldn't be. Like that should be hidden away and abstracted away by like the Hazel core kind of library. And so sometimes that will happen and it'll be like, why on earth, what's include, what could possibly be using like, a Vulkan file or whatever that we might have inside Hazel inside a place where it shouldn't be. But with this, it's really easy to just be like, all right, so I know this is being included, but where is it being included from? Oh, I can easily just kind of trace this down and see that like, oh, okay, for example, if this like Windows kit thing was like, let's just say it was Vulkan code, I could be like, oh, okay, it's SDL platform. That's what includes this stuff. And that's not allowed to. So this kind of show includes thing is also really, really useful. But the reason why I brought it up here is because it kind of lets us just see potentially, what includes game.h. Now in this case, not quite, because obviously I'm compiling game.cpp and I'm just seeing what is included inside game.cpp. But another quick and dirty way to just quickly see, let me just move this output back, to quickly and easily see like what is actually including a specific header file like game.h is you can just stick an error in it. So if I just do hash error lol or something, right, and I compile everything, then let me turn off show includes because that's gonna pollute my output window. You can see how many lols I get, right? So I got a lot of lols there. Let's dock this in here again. Maybe I'll take the output as well. So you can see that in the error list, which just parses the output, I have 5 lols. And then over here in output, I also have my 5 lols. And I can actually see, well, actually the error list might even be better. No, it's just because it's in game.h. But in output, I can kind of see, and this can be difficult because if you're doing, like, if you're compiling in parallel, it might be difficult to see, but you can see bird.cpp must include this. I actually don't know if this is going to build in parallel or not, but whatever. Game.cpp includes game.h, game intro includes game.h, game outro, and main, right? So these things all seem to include game.h in some way or another. They couldn't, like some other header file might include it, but the point is because these are all sent to the compiler as kind of individual CPP files, that's why I get this error 5 times. Because it's trying to, obviously independently from anything else, it's trying to compile this one file, which, bird.cpp, which if we look that up, you can see that, yeah, that does include game.h. So my point in saying all of this is that that's one downside that you have to consider when you do write a function here. That if I do actually change something, like, oh, this actually needs to be true or whatever, then suddenly I have to recompile, like, this header file has obviously changed. So every CPP file that includes that header file in one way or another now needs to be recompiled. And that can be annoying because that will just make your build times larger. Whereas obviously if I had just been like, okay, this is going to be now declared over here, sure, that's not going to change. I'm not going to change the signature of this function or the name or something, but the contents of its body, which are now obviously in-game.cpp, that's a CPP file. So just that one kind of file, that one translation unit needs to be recompiled, and the header file that doesn't, like, you know, not all of these. So instead of recompiling 5 CPP files, I'm recompiling 1 CPP file, which will just make your build times faster. So that's why, you know, it's nice not to do this. But again, you know, I would say if it's something like this, you know, and it's like this is not going to change really, like return end, and it's kind of clear to see what it is, and it doesn't make this more, and like maybe it'll be more likely to be inlined, although that's a weird thing. I have to look that up. I'm not sure I quite buy that. You know, for something like player init, I would definitely basically cut that out, and then I can just quickly use Visual Assist here. You can use Visual Studio as well, by the way. I don't even know what it is, but there's quick actions and refactorings, create definition, right? So that's the Visual Studio way of doing it. So if I now go to that, it's just a bit annoying. I think I like Visual Assist's version more. Then I can just paste that in, obviously now. Let's go ahead and straighten this out. It was just one line of code, I guess, but it was there for some reason. Okay, so that's the one line of code. Now it's here, and we've moved that there. Now, of course, if anything changes, like maybe I move this to a different directory, I don't have to recompile the files. Again, not that it's a huge deal to recompile those files. Like, sure, it might be like 3 seconds instead of 1 second to build everything, right? It's not going to make a huge difference. But obviously, this is just a habit that is important because sometimes, like, you know, for me, like sometimes if I change a header file in Hazel, I might have to wait over a minute to get that to rebuild, especially if it's something that might be included by like a pre-compiled header. Anyway, it can get, like in a large project, it can get really annoying to obviously do this, which is why like it's really good in C++ to just get into the habit of not doing everything inside header files, but instead like using those implementation files. They're kind of there for a reason. So yeah, these are mostly okay. The other thing I would say is obviously for like functions that just return values like this, and especially if they copy it and not like return it, you know, by reference like this, make sure you mark them as const. And what that does is it just means that if you have a const game object somewhere, so you've passed a game by const reference, for example, then you can still call this function. Whereas if it's not const, then you won't be able to call it because the copy of game you have is const. So therefore, stuff that modifies game, you know, for example, this writes to game's memory by setting end to false. This can't be const, and therefore you wouldn't be able to call, you know, set ended false. And you can see if I add const here, it'll tell me it's an error because it's not modifiable. Unless, little cheat here, is unless you make it mutable. So if you make this mutable, then you can see over here that now I can actually set end to false, which is a little bit weird, but that's again because you've made it mutable, you've made it changeable. So that's like a little cheat thing. Why does that exist and why is it useful? Probably a topic for another video, but usually I like to do that if there's something that is like auxiliary, I guess, to what the function's meant to be doing, then that might be like an appropriate use of that keyword. But anyway, we'll get into that later. Anything else here on the topic of header files? There's also some weird stuff over here, like, you know, there's all these functions, and then amongst them there's like this static public, you know, STL renderer thing. So what I like to do with that is I would cut that out of this so that again the functions are kind of first, and then under here I'd make another public label and just put that here. And of course, like, you know, in my convention this might be like sRenderer, or if it is actually public like this, then I'll probably capitalize it. That might conflict with a class name though, and especially some other compilers. MSVC is usually fine with that. Even if you know, had something like this, it would kind of discern that that's the variable name, that's the type name. But other compilers like Clang and GCC might not be happy with that, so you have to be careful. But otherwise, if it was private, then I would call it something like s_renderer, the S standing for static, of course. Okay, so that I think is pretty good. Next time, we're going to look at this disaster and how we can rewrite this probably to just make it look better. And probably, I'm expecting the implementation side of things is probably also like a little bit difficult to deal with. Yeah, like there's, you know, all this looping through all this kind of stuff, and like maybe there's some things we can do to kind of improve that code, because I'm just thinking this isn't probably not the best thing to do. Anyway, I hope you guys enjoyed this code review. If you did, please don't forget to hit the like button. I like to make these code review videos as kind of like just a let's talk about code. It's like a discussion. So if you guys have anything to add, then definitely leave a comment below. Don't forget to check out brilliant.org/thecherno, and I will see you next time. Goodbye.